Hi and welcome to this video about RunDll32. So what is RunDll32? This is an executable that exists in any Windows installation. There are two variants of that executable, a 64-bit version and a 32-bit version, which is stored in the syswow64 directory. And its purpose is to run functions within DLLs. Basically what it does is very simple in the sense that it loads the DLL in question, gets the address of a function you'd like to invoke, and then invokes that with some arguments. That's basically what it does. In actuality, it's a bit more complex than that, but it's not that important for our purposes here. And so RunDll32 can be used to invoke functions within DLLs. That's the basic idea. In order to do that, you need to run RunDll32 with the name of the DLL, then a comma, then a function name. You must be careful not to have any spaces between the DLL name and the function name, and then extra arguments that are going to be passed in some way to the function. I'll show you exactly how that happens a bit later. Once that is done, then RunDll32 will try to do what it is instructed to do. And if there are any errors in finding the function or finding the DLL, it will pop up a message box to indicate that kind of error. If there is an error within the actual implementation of the function, then there's no good way to get that information back. So here are some examples you might want to use RunDll32 for. So one thing is various dialogues that can be invoked using RunDll32. In some cases, that's the only way to invoke those dialogues. You can see a few examples here. We can try them out. Let's see if we can try some of these things out. So we have RunDll32 here with sysdm, which is a control panel application. Control panel applications have a CPL extension, that's the typical extension, but really these are just DLLs that expose various functions. In this particular example, this sysdm DLL exposes this function called edit environment variables. So I need to be very careful here to provide the correct function name, including case. And if I do that, here's what popped up on my other screen. This is exactly the dialog to edit environment variables. Of course, you can always see what's in there just by looking at the exported functions in any DLL, just like we do in any normal DLL. And so I can use something like total.pe here, and I can grab a directory like system32 here, and I can even filter for control panel if I'm interested in control panel applications. There's quite a bit of those. And although Windows is moving away from the control panel into the system settings application, the modern one, so to speak, still many of those still exist here. We can definitely use them in the context of a control panel and by invoking certain DLLs. Certain functions from these DLLs. So if I grab total.pe here and I take one of these things, like drag it here like apewiz, we can see that if I use the exports, there's a bunch of functions here, and technically they all could be called by using RunDll32, but some of them require certain parameters which we can't really pass properly using RunDll32 because those functions don't expect the parameters in a certain way, but some do still work. So for example, this config start menu should work and do something for us. So again, we can try this using RunDll32. In this case, it's apewiz.cpl, and the function name is config start menu. Once we do that, we should get something like this, which allows us to customize shortcuts, things like that. That is perhaps a very old way of doing things, but it's still very much supported, at least it works. Now, of course, we can look at other DLLs, which are not necessarily control panel applications. A few other examples here include something like Shell32. Shell32 is just a DLL, just like any other, but it has many exported functions. Some of them are conveniently callable by RunDll. So again, we can try this out. For instance, you're probably very familiar with this idea of telling Windows which application should be used to open a certain file based on its extension. So in fact, we can invoke that thing directly using the function openAs_RunDll with some file name. And we don't actually have to provide the full a correct file name that may not exist, but just have appropriate extension. So that now we have this dialog popping up, and unfortunately it pops up on my other screen and I can't really move it around because it's not a movable dialog. It's kind of annoying. But you can try this thing yourself. Anything you pass here, it's going to open the open as a file dialog there, which again, unfortunately, it pops up in the wrong screen. So you can try these things out. The other thing that you can try, which is a thing very cool, is the ability to run any control panel application using the function control RunDll from RunDll32. So basically what that means is that control panel applications themselves are actually DLLs, as I mentioned already, and they have to expose this function that is the kind of the main entry point for that control panel application. And this happens to have a particular name, which we can definitely use to run that kind of thing from the outside. So again, taking another example here, the function actually is called CPL applet to be opened as a control panel application. So let's try something else here, like a power CFG. Let's see what we have here. So you can see the function CPL applet is the one that needs to be implemented by a control panel application. But in general, we can invoke these applications using a function from RunDll32. So you can do RunDll32 with RunDll, of course. And the function here, as you can see, is called control_RunDll. So you can do control_RunDll. And so I can try any CPL file, basically, like appwiz.cpl. And it should work, and we get the add remove programs, the old one that is still actually very useful, but we just get it here directly. Another example was that power cfg.cpl, and if we try that, and of course if I have to do that correctly, so power cfg. Let's make sure I'm writing these things correctly, and we get that power applet here. And in fact, in some cases, you can even pass these parameters that would force a different page in that application to open up. It's not, of course, documented officially, but you can perhaps figure it out with some experimentation and reverse engineering. So in general, that's the way you would use RunDll32. Now, how do you get parameters to the invoked function? What happens if you want to write your own DLL to be usable by RunDll32? So this is the function as it is expected by RunDll32. RunDll32 provides 4 parameters that are passed to the function. So the function has to be properly built in order to accept these parameters properly. Otherwise, it just won't work and the interpretation of parameters would be wrong and the target function will simply misbehave and probably fail. So the first parameter is the handle to window to some window that you can use as a parent window if you need to present any kind of dialogues. Usually it's the desktop window. It's passed by RunDll32. There's nothing you can do about that. You just get it. You can use it or not. Then you have the instance DLL of the DLL itself, which is basically the address into which it is loaded into RunDll32 process. And this allows you to very easily access your own stuff like resources you might have in the DLL, like icons, dialog boxes, strings, and so on. You can always get that from your DLL main function that you write, but still you get that here kind of for free, so you use it if you need it. And then there's the last parameter, which is the show parameter, which is just a value indicating how should you show your main window if you have such a thing. Usually it comes with this value as wShowDefault, which really just doesn't mean that much for this kind of case. It's still here for compatibility reasons. The only parameter that is actually controllable is the command line parameter. This is where you get the extra stuff that is provided by the command line that is used to invoke the RunDll32 application. This is where you pass your parameters and the function needs to properly make sure that the parameters are expected and do something useful with it. So to demonstrate that, let's go ahead and write our own DLL that we can invoke from RunDll32. So I'm going to create a new project. I'm going to start with the desktop wizard template, which would allow me to create a DLL very easily. So let's call that simple, being a simple DLL. Let's put that into my YouTube code directory. Let's call the solution RunDll and use create. I'm going to choose a DLL here, and I'm going to just say, let's export some symbols for simplicity, just give the wizard something to do, and that's going to be good enough for our purposes here. So the wizard works and it generates the files that are expected here. So we get some basic code here, like DLL main. This is nice, but not really useful for our purposes. Let me just zoom in a little bit here. We don't really need it. I'm going to skip it. Let's go to some other file here like simple.h. With simple.h, we have some dummy class here for exporting purposes. We don't need it. Some global variable, we don't need it. And a function we want to export. This is something we do want, but I don't really need this declaration here. Just you're going to provide the definition because it's always going to be invoked dynamically. So again, I'm going to go to the CPP file, remove all this junk here. Let's just leave this function here, remove the constructor for this class, and now we have the function. And so the function has to be with that particular prototype, meaning void. The function could be called whatever I want. Let's call that test for now. And we have the handle to window here. We're going to get an H instance. And then we have the command line, which is what we really are after. That's the important part. And then there's the show parameter, which we don't care about. So we have a void here, and what I'm going to do here for my first example, just use a little output debug string here to output the command line to the debugger output if the debugger is attached, or to some other tool like debug view that can capture this output. Okay, fine. Let's try to build this. See what we get. Let me open the Explorer here to see what we get as the final result from the binary perspective. Let's go to the DLL itself. Here goes. Let's drag it into total PE and look at the export. So you can see that the export seems to be not exactly as we'd like it to be. You can see the undecorated name is in fact my test function, but unfortunately because of name mangling, because it's interpreted as a C++ function, it looks really bad and won't be able to work. We would have to provide this exact string in order for the function to actually be identified correctly, which is of course not what we want. We want a simple name like test. So the only thing you need to do here is just to have extern C here to say that I'd like this function to be linked as a C function rather than C++ function, and for C we don't have this name mangling. This simple API macro, by the way, is defined this way, that provides a special declaration here to the Visual C++ compiler to say that this function is exported. This is one of the ways to export functions. And this is what we get from the wizard by default, so I'm just rolling with it. So once we do that, let's try it again. Let's go back to the DLL and see what we get in the exports. And you can see that now the function is called exactly test, exactly as we want. So that's good. Now we can actually test it. So I want to put a breakpoint here. But if I try to run this, of course, it won't really work because it's a DLL. You can't just start a DLL. It's not an executable that you can run independently. And so we can go to the properties of the project, go to x64 and debug, go to debugging here. Instead of using the command as the executable, which is actually the target path, which in this case is the DLL, I'm going to change that to RunDll32. Just to say I would like to run this thing when I try to debug this project. I'm going to pass some arguments here, and of course we need to provide the arguments in the format that RunDll32 expects, which means we need the name of the DLL, which is called in this case simple. It's going to be simple.dll, and then the function name, it's going to be test, and we need to make sure there are no spaces in between, and then whatever else we would like to provide, extra parameters. Let's use hello123, see if that works. I'm going to click OK and press F5 again to run this. And you notice that we get an error saying there was a problem starting simple DLL. The specified module could not be found. It makes sense because RunDll32 running from the system32 directory doesn't find simple DLL. We have to provide the full path here because simple DLL does not reside in one of the default searched paths. So in order to do that, the simplest way of doing that in Visual Studio is to use the $target path environment variable here that Visual Studio understands as being the full path of the thing that we're building, which in this case is the DLL. So I'm going to do that and then click OK. And now, if all goes well, we hit the breakpoint. You notice the application is indeed RunDll32. That's the thing that is actually running now. And it's calling my DLL. So we have a handle to window here. We have the H instance of the DLL, which is our DLL. And then we have the command line. And that looks completely weird. It's supposed to be hello 1, 2, 3, but it looks something completely different. Looks something like Chinese or something like that kind of characters, which is definitely not what I expected. The command line doesn't seem to be working well. And you might be able to guess what the reason for that is. And the reason is that this LPTSTR means that it's actually going to be interpreted as a wide string. And unfortunately, the normal way that the RunDll32 works is by assuming the string is ASCII. So one way to fix that is to just change this to something like this. And we'll have to use the A function here to output the string. So I'm saying this is a normal ASCII string rather than a Unicode string. So notice that now we have the correct command line, that is the extra parameters we provided in the command line, hello 1, 2, 3, and it works as expected. However, in some cases I still might want to use Unicode strings, because maybe I want to pass that to some Windows API and like to use Unicode instead of using ASCII. So the way to do that is to change the name of the function to include the suffix of W, being the wide version. And now the function that's being exported is called testw, but still it's going to work out correctly because RunDll32 has some logic to test that to look whether the test function exists, and if it doesn't, it's going to append a W and an A and see if that works out. If it does, it passes the parameters as expected. So you can see the command line is now correct again, but now it's a Unicode, a wide string. So you can work with that if this is what you want to do. So it all seems to work just fine. We can invoke this test function. So let's do something which is perhaps marginally useful here. Let's create something that allows us to terminate a process. So let's call that something like kill process. I'm going to use the ASCII version. That's going to be good enough. Let me just grab here because I'm going to assume that the command line is a process ID. So let's go ahead and grab this process ID using the simple A to I function by providing the command line here like so. And the A to I might not be supported. We need to add something here to make it available, like string is going to be good enough. And then we can say if the process ID is not 0, even we don't actually have to test that, we can just go ahead and try to open a process with this ID, with the process terminate access mask. If this works, great. If not, then it's just not going to work out. So if this works, I'm going to just go ahead and terminate the process by providing the handle and some exit code of my choosing. I can close the handle even though it doesn't really matter that much because the process is going to shut down anyway. So that's my implementation here. Let's try it. Of course, we can try it using the debugger, but let's try it using a command line. Just go ahead and try to invoke that like another application would or a user would using RunDll32 in itself. So I'm going to go to this directory so I can use RunDll32 here and with my simple .dll. The function is called kill process, and then I can provide parameters. So as usual, I'm going to choose some process here. Here's a notepad process here we're going to use for demonstration purposes. I'm going to open Task Manager to figure out its process ID. That's going to be 16496. Like so, and here goes. You can see the process is gone. If it's something that can't be killed, it just won't work, and that would be it. Now I might be asking at this point, why would I want to write a DLL for this purpose? Maybe I can just write a normal application that has the ability to terminate a process given its ID. It's definitely something I could do and parse command line parameters in basically the same way like a normal application would in a main function. So there might be two reasons for this approach. One of them is since I'm writing a DLL, it means it can be used by anyone. could be used by any executable or another DLL, which is the basic idea behind DLLs. You can share them. It can be used by many processes, not just one. The second reason could be because I would like to have my application or my code being more stealthy. Because now when anyone tries to terminate a process using this approach, what anyone would see on the outside is a RunDll32 process running, which is a very common process that runs on today's Windows system. So it's not going to be suspicious or anything going to be visible up front as what is going on inside it. So I might want to create these DLLs, which are not in themselves runnable directly, but could be run indirectly by some other application, in this case RunDll32, if I properly provide a function that looks like this, which I've done here. In fact, I had to probably add std call here. That's the standard calling convention, which is necessary for proper stack cleanup. It's not necessary for x64 because there's just one calling convention and std call doesn't really mean anything, but for x86 it does mean something, so you want to make sure things are exactly right. But other than that, that's how you write functions. And of course, I've written just one function here. You can have any number of functions that have the same prototype but do different things, and they could be invoked from the outside by using RunDll32. So that's RunDll32 for you.